So today I'm going to talk about the unstoppable secret superpower of WebRTC. My name is Greger Hemb, and I'm a senior knowledge engineer at Competence, which just means I'm a consultant. This entire presentation is available online at bit.ly/WebRTC, if anyone wants to just see it. So today we're talking about WebRTC, featuring the unstoppable data channel. But before we start this journey, I just need to say up front that you don't need to know WebRTC to gain any value from this talk. I will show you the basics before I jump into the deeper parts of the presentation. But that means we're ready to start the journey to the data channel. In this presentation, I'm going to kick it off with the basics of WebRTC, just getting everybody up to speed on what it is. Then moving on to story and demo, that's always fun. Connecting users, how to connect two browsers together using WebRTC, showing actual code. Then of course diving into the deeper parts of the data channel. Browser support, which is actually kind of nice. The latest news for WebRTC of the latest year, sort of. And of course ending with a call to action, motivating all of you to learn more about WebRTC when you leave this room. So, in a nutshell, what is WebRTC? This is oversimplified for a reason, just to get everybody into the right mindset for what it is. But before I start, who here is unfamiliar with WebRTC? Haven't tried it at all? Oh, perfect. Then it's really good I have this start to the presentation. So, in a nutshell, it is a direct browser-to-browser communications API. We're talking from one browser directly to another. It's an API for real-time communication, sending a message from that one browser to the other and expecting it to be delivered as fast as possible. You can think of it like WebSockets just directly between clients. Because usually WebSockets are between a server and a client, and now it's directly between two clients, or at least the data part. You have dedicated channels for video, audio, and data, and you have something called a media engine, which is just a fancy wrapper for a lot of functionality that you need but you don't think about, like acoustic noise cancellation, upscaling and downscaling on video, and all that fun stuff. So you can focus on actually making the application you want to make. And simplifying it even further, it's an API. Can you still hear me? Yeah. It's an API for creating what you know Skype to be, but at least back when everybody were using it, in the browser, yourself. Like Skype used to, or still have, file sharing, chatting, video conversations, group conversations. All of that is something you can make in WebRTC yourself in probably a few days if you just sit down and learn it. But we need to talk about the traditional model. It's a server in the middle. A server sitting there in the middle with all the clients connected directly to it. This is not what WebRTC is. WebRTC skips the middleman, communicate directly. Each client can potentially be connected to all other clients. This is also known as peer-to-peer. However, two browsers cannot contact each other directly. Like, you need to meet at something called a signaling server. But what is that? A signaling server is a meeting place. Because the thing is, your computer, in order to be called, you sort of have to have an internet phone number or a public IP and port. But the thing is, my device at least, I don't have that dedicated to that device at all time. So if I'm going to call someone, I have to meet them at a place and exchange my current internet phone number, sort of IP and port. So the signaling server is just a server somewhere on the internet that you meet them and exchange sort of contact information for calling each other. One way of thinking of it is like everybody knows about Tinder. Imagine you're going on Tinder. You're swiping a bit left, swiping a bit right. Suddenly, you're matched with someone. You strike up a conversation and it's going really nicely. And of course, then you start exchanging phone numbers. And once you have exchanged phone numbers, I usually stop chatting on the application and switch to just sending text messages instead. That means you have used Tinder as a signaling server for your text-based communication with whoever you matched with. That is what the signaling server is in WebRTC. Once you have done the signaling part, matched up, you can just kill the server. You don't need it anymore. But before I move on, I should just state that there's a hiccup in the learning curve. This image has nothing to do with WebRTC. Don't get scared by it. It's just from a game I used to play. But there's a small problem in the learning curve of WebRTC still. Like getting the video locally on screen and showing it is easy. But going from that point to the point where you're connecting two browsers together, that is hard, because there is nothing like a half-connected browser. Either you're not connected or you're connected. But if you follow along on this presentation, I will show you how to do that. And once you reach the point of connecting to browser, it's smooth sailing. It's a lot easier learning more about WebRTC from that point. But of course, I had some difficulties creating this presentation, because there was someone that wanted my attention and thought I was spending too much time on making this presentation. I just wanted to include my dog in this. So, how did I learn WebRTC and found the mysterious data channel? And you might be thinking, why am I telling you this story? And the reason is, I've talked to a lot of other developers learning WebRTC, and most of them had the same problems to overcome as I did, because there are some problems you have to overcome when you learn WebRTC. And seeing off that you will be able to overcome them, and how to do it is really motivating when you're finally sitting there down and learning it for yourself. So, let me set the setting. It was one late night in 2017. And yes, 2017, WebRTC came out in 2011, 2012, which means I was really late to the party. But that is not a problem at all, because it has changed so much since then, that if you learned it back when it came out, then you have to relearn it now. So getting into WebRTC now is actually the perfect time to do it. But anyway, I was sitting there one late night in 2017, browsing the web, as I always do, and suddenly I came across something new called WebRTC. And I didn't understand it originally, but I kept reading because it sounded interesting. And I found out, like, oh, you can have one browser and connect it to another browser. Okay, this is starting to sound cool. You can send files, you can send chat messages, you can have video conversation, all that fun stuff. Okay, this is something I have to learn. So I kept looking, finding a few tutorials, but they just showed me the basics. They just showed me how to get the video locally and show it on screen. That is nice, that is cool, but I wanted to go to the step where I connected two browsers, and they did not show me that part. So I got furious. I kept searching, looking for tutorials that showed me this, and finally I found a few with signaling, the entire stack for how you connect to browsers. But yet again, there was another problem. They did not show me actually how to do it. They just showed me how to use their own subscription model, where they provided the backend, the signaling part, in exchange for a lot of money. And you shouldn't say yes to that when you're learning something new. That just destroys the entire concept. And in my opinion, the backend, the signaling part, the part I needed to pay for, is the easiest part of WebRTC. You can just 30 lines of code and you're done. So don't pay for that when you're learning it, at least. So I kept looking, and finally I found one. It was an old tutorial. It was outdated just by a year, but that was enough back then for it not to work when I ran it. But I was so close. And nicely enough, the backend in the tutorial was in Node.js, which, like the same language in the front end and backend, always makes it easier. So now I was really motivated. So I looked at the errors that popped up, looked at what I've changed in the specification since the tutorial came out, and looked over it, tried to fix everything I could, and finally connected to another browser. That is probably one of the most amazing experiences you will ever have when you're learning WebRTC. That moment when data, video, audio flows directly between those two browsers. But of course, it was done in as a dirty way as possible. It was a mess, it was horrible, but it was working. That's the important part. So, of course, then I took the mess I just made and rewrote it in Angular. And the reason I chose Angular is just because it's my preferred one. You can use React, Vue, Native, anything. But I remade it, and everything I'm talking about is available on GitHub if anyone wants to see the code at some point. But while I was redoing it, I kept reading the tutorials, and I saw it in the distance. I didn't really understand it originally. It was mentioned in like, oh, by the way, in the tutorials. I didn't see the importance because I just had video flowing between clients. But they were talking about something called the data channel. So I didn't understand it, but I kept looking. It sounded a bit interesting. So reading a few tutorials, I suddenly realized you can send chat messages, you can send files, you can send data. Okay, this is starting to sound amazing. So I read those tutorials again and implemented them. And suddenly I was sending gigabyte-size files directly between two browsers that could be on either side of the country. Okay, this is amazing. This is really cool. But each time I ran the application, this thing popped up. Hi, this website wants to steal your video information and sell it on the dark web. Like, no user is saying yes to that if you're just making a simple file sharing service. So it's like, oh, all that potential lost just because of that horrible pop-up. But wait a minute. I probably can't read it, but I'm going to say it. I looked more closely at the pop-up, and it said like, hi, do you want to share your camera? Do you want to share your microphone? But it said nothing about sharing my data or allowing any data connection. So it's like, if I remove the part of the code that asks for a user's camera, and just remove everything related to that, and rerun the application just with the file part, and suddenly I was left with limitless, permissionless potential, as there was no pop-up blocking me from using the application. I could establish a direct communication channel between two browsers without asking for permission from the user. That happens to be the basis for the rest of the presentation. But that means it's about the demo. We should look at the demo. And just one interesting thing first. What I'm about to show you, everybody can try that in this room, but not until the end of the presentation, so you don't get distracted when I'm presenting the rest. And I made the demo to be as simple as possible, because you should be able to understand what's happening and potentially remake it yourself. It's just a drawing application where two browsers, as they connect to the shared backend, are automatically matched together. So if I just draw on either, it's replicated over the data channel to the other browser. And of course they have separate colors. Just simply taking the draw event and replicating it on the other computer. But this opens up, you can send anything between them. I'm going to show how you can actually do this later, and everybody will be able to try this demo later. Right. So the really simple demo here is available on GitHub if anyone just wants to poke around with it. Because when you're learning WebRTC, finding a working example is really important. And the front end is just in Node.js, and back end is in, the front end is in Angular and the back end is in Node.js. But you can use either, it's just my preferred two. And it's really simple. It's just using canvas for drawing, like here's a point, here's another, draw a line between them, based on where the mouse is. We use WebSockets for talking to the backend, and the backend is just Node.js, and all it does is matching. Like one user joins in, it's kept on hold, the next user comes in, and they match together over the data connection, and they just can kill their connection to the server. Then they're just talking directly to each other. And I just send any draw event over the data channel. It's really simple, but you can send a lot more, which I'm coming back to. But that means we are ready for a deeper dive into WebRTC. How does it actually work? Now I'm going to show you how to connect two browsers together with not that many lines of code, actually. It's kind of easy when you look at it. But the first thing you have to do when you're making a WebRTC application is getting the user's media. Because I'm showing the entire step, video, audio, and data. You have something called navigator.mediadevices.getUserMedia, and you just say like, hi, I want video and audio. This is what triggers the pop-up to the user, asking them to give permission for giving the camera, and they can like select which camera they want, for example. And if they say yes, you get the then handler fires, and you can take that media stream you got and append it directly to a video element on your page, and suddenly you have the images coming from your camera showing up on screen on your computer. It is that simple. So, then we are ready to actually dive into the WebRTC part. And there's two fancy words. RTC pair connection, that is just a master object where you like feed in all the information and get out all the information regarding WebRTC, like how to connect to users. And stun is just a way of finding your current public IP and port. It is a server provided, for example, freely by Google, so you don't have to make it yourself. Would you like to just provide a stun server, Google has them, and create a new pair connection object? Easy. Then you have just gotten the local video stream from the user's camera. Now you need to add it to the pair connection so it can automatically send it to the other side once you're connected. That's easy, but your local video stream contains two things. It contains video and audio, two separate things. So you need to take each of them, for each of them, and add them separately. But then you added the video. And at some point in the future, the video from the other person will start arriving. So you need to handle that. And that is really simple. It's an event that fires. And then you have the media stream as when you're getting it from the get user media. And you can take that and append it directly to a video element on your page. And suddenly you have your local video in one video tag and the remote in another. Now, and then we set up the data channel. A bit more code, but it's a lot of boilerplate code. Because options, for example, is probably not something we're going to do anymore, as reliable is default. And just create a data channel with a label. It's just a handy way of naming it for you. And on that data channel's creation, you have the event channel.on message, which is just what fires each time you get a message from the other end of the data connection, from the other browser, sending something to you. And sending anything, that's just .send, nothing else. Now we're ready to connect to the other browser. We meet at a signaling server. But technically, I keep lying to you, you don't have to meet at a signaling server. Because the thing is, in order to connect, you just have to take some piece of text information generated on either computer and get it to the other. Which means, in theory, that you can console log out that information, put it on a memory stick, attach it to a pigeon and send it flying to your friend, and he can use that to connect to you. But it's way easier with a backend because it's like 5 to 10 messages from either computer, 5 to 10 pigeons, that's a lot sending back and forth. But I suggest using WebSockets as since it's 5 to 10 messages, then you're sending them really fast between clients. But now it's time to make the call. We create and send an offer. That is a session description. That is just a description of who you are and what you support. Your browser, like what browser you're using, what codecs do you have, all that fun stuff. But you don't have to think about it, you just have to make it and send it. You're on RTC connection, creating an offer, and then it's your job to take that offer, send it through the signaling server, and to the person you're going to call. And set it as your local description. Then the other party, the person you're calling, needs to take that offer and generate an answer based on that. They set the remote description of the person who's going to call them. They're going to fill in the offer there and generate an answer. I just send it back. And on the first person side again, you're just adding in the answer as the remote description. So each party has a local description of themselves and a remote description of the other person. Then it's time for ICE. That just stands for Interactive Connectivity Establishment, which nobody knows. Wait, does anyone know what that actually is? Like one. Just to simplify it, it's a way of mapping out the network between you, like what's the optimal way of connecting the two browsers together. And that is just, it's generated automatically, it just keeps firing once the offer and answer has completed, and your job is just to take it from either computer and get it to the other computer. And once the final ICE candidate has been sent, it's time to connect. And that is nothing. It happens entirely automatically. But if the firewall of either of you blocks the connection, you have to fall back to a relay called turn. And those are expensive. Those can't you find for free. But anyway, if you either connect it directly or use turn, that means you are connected. Two browsers directly connected, sending video, audio, and data directly between them. Amazing moment. So, I think it's important to summarize the steps in one page just to see it's actually not that hard when you think about it. You just meet at the shared backend. You create a peer connection with Stun. Stun was just still a way of finding your public IP and port. You get video, sound, and data. You send an offer and receive an answer. ICE candidates map out the network between you, finding the optimal way to connect. You might fall back to turn if the firewall blocks you, and you're connected. How to do WebRTC in 6 simple steps. And yeah, just take an image of that if you want to. But that means we are ready. Now we're diving into the data channel, into the deeper parts, into the main parts of this presentation. Because you can send almost anything. You can send strings, which means you can stringify JSON objects, which means you can send any state, more or less. You can send blobs, you can send array buffers, you can send array buffer views, which means you can send files. So now we have a lot of potential. So let's just look at a few examples. You can send chat messages. You can send files. You can send any state, game state, drawing state, reader state, take your pick. And you can send, you can, for example, create a BitTorrent network with your friends, sending legal files between you, if you want to do that. You can do data streaming from one, for example, one IoT device to another using WebRTC. It's a data channel. You can even do decentralized computing. It's like taking a giant problem, breaking it up into smaller chunks, sending them to all of your friends over WebRTC, have them solve them individually, send the solution back, and you have a combined solution. That's decentralized computing. You can even create a content delivery network purely in the front end without asking for permission. Like, this is starting to sound a bit evil. But how do you connect two browsers together only using the data channel? And now you might be thinking, oh, I have to do the entire step again, a lot of new code. No, it's the same as I showed you earlier. You just remove a few lines of code. Since you're not going to send any video, then you're not getting the video from the user. And this is what triggers the pop-up. So removing this line removes the pop-up asking for permission before you create a connection. And since you're not getting the user's media, then you're not adding it, and you're not expecting it. Removing those 3 lines of code, and suddenly you have a data-only connection without asking for permission. So, I think we should talk about how you use the data channel. We need to see some actual code here, like not just examples. Let's look at a few examples. First, we have secure end-to-end chat. And that is just a fancy word for, like, you're sending a message from one person to another without anyone in the middle being able to read that message. Not a server, and not anything. And since WebRTC is secured already by default, that means you send it in plain text. This is how you create a chat application in WebRTC. You send messages and you receive messages, nothing else. And maybe you want at some point to send files. That is actually not hard either, but there's one concept you need to be aware of. You can't send the entire file at once. WebRTC limits you to 64 kilobytes per message, and I'm going to come back to why. But that means if you're sending us a giant file, you need to split it up into smaller parts of less than that size, send them individually over, and rebuild the file on the other end. So that's what I'm doing. Creating a file reader, reading a slice of the file, reading it as an array buffer, which is something you can just send directly over the data channel once it's loaded. And then, on the receiving end, you just continually add the incoming data to a buffer. And once you've sent the entire file, all the small parts to the other end, you create a blob and you have the file. Then you have sent the entire file to the other person using WebRTC in only these lines. However, there's one small thing, like you have to send the metadata for the file separately, like the name of the file, how many chunks are you expecting, and all that fun stuff. That can be just sent as a text message or something. And what about state? Like the demo I showed you, where you draw it on one computer and sending it to another, like the drawing app. The first thing you have to think about is, are you sending the entire state or the change to the state each time? That's a discussion on its own, but simply, if you're sending just a change, it's a lot less data, but you can get out of sync if something happens along the way. But if you're sending the entire state, you're sure everything is synced up, but it's a lot of data. But that is what you're doing. You just stringify either the complete or the change the state, and parsing it on the other end. And suddenly, you can link up the Redux state of two websites across browsers. Imagine you have like a hotline service for your website where the customer service can see the state of the website for the user that has a problem in real time. It can be useful. But why couldn't you send large messages? Why were you limited to 64 kilobytes? Why can't you just send that entire file? That doesn't make any sense. Let's talk about large data channel messages. And it's due to something called end of record. That is just an indication on each message being sent of if it's partial or complete. Because the thing is, and a lot of browsers have not implemented this correctly. Let's imagine Chrome for a moment. Two Chrome browsers are connected together, and you're taking a file of 100 megabytes and sending it at once. Then the browser is supposed to take that file, break it up into smaller chunks, and send them individually for you. But the thing is, like you're sending the first chunk over, and the browser says like, hey, this is not the end of the message. This is only a partial message, expect one more. And Chrome is like, nah, this is the entire thing. So I'm sending it on. And once you send the next packet over, it crashes. So this is an incorrect implementation by the browsers. However, good news. Thanks to the new EOR feature, Firefox now supports receiving up to 1 gigabyte messages, which means in Firefox, between two Firefox browsers, as coming to rest, you can send up to 1 gigabyte files directly without breaking them up at all, which is really nice. And the reason it's not higher is because the entire message needs to fit into RAM before you can send it. So like Firefox only supports down to, I think it's around 1 gigabyte on the smallest devices, so then you're limited to 1 gigabyte. And coming up from 64 kilobytes, that's amazing. And of course, it's backward compatible, so Firefox can talk to the old Chrome, which haven't gotten the update yet, but you're probably going to get it. But that is a good time to talk about the elephant in the room, browser support. Like the reason everybody has not been using WebRTC because it's like supported in one browser and it's horrible. But the thing is, it's really, really nice. The browser support has increased a lot. Like if you're ignoring the Microsoft part of this and all the smaller browsers, all the major browsers, even on Android and iOS, supports it now. However, like you see that there that iOS, Safari, and Safari, it's green. Like that's a lie. Let's talk about Safari for a moment. While I was doing this presentation, I kept looking over the bug trackers for all of the major browsers and what's happening there. And the Safari implementation, it's experimental and buggy because it's really recent. Like it came out in the last year, as far as I remember. And of course, there's a lot of problems, as Firefox and Chrome was back in 2011, so they had so much more time to fix things. But I was looking over the bug tracker, and suddenly I came across a bug where it was justified as a feature because Safari fails to establish a connection unless get user media is called. Contrary to Chrome and Firefox, we do not leak private IP access unless camera and microphone access is granted, which means you can't have a data-only connection in Safari, and that just destroys my entire presentation. Like, why am I standing here talking about this if it doesn't work? But there is good news. Really, really recently, they reverted it. So it has been fixed. luckily. So now you can have a data-only connection in Safari as well, thankfully. And one more thing, if you can read that low, WebRTC only works in Safari on iOS currently. And that is a limitation Apple has put in place until they feel it's ready for the other browser or skins. So, maybe we should talk about the browser differences for a moment. What's special about each browser when it comes to WebRTC? Like Firefox, that is the most up-to-date browser, which means if you're developing a WebRTC application, use Firefox. And that also means that Chrome is lagging behind. And Chrome was the original pusher for WebRTC, but now they switched it around, so Firefox is in the lead. But like when I'm saying behind, it's like just slightly behind. And we talked about Safari. It's recent, it has some issues, but they're either fixed or going to be fixed. But of course, if you're trying to use it, you might experience some troubles at points. And on iOS, it's only in Safari for now. But on Android, it's really great. Like with Firefox, Chrome, the Samsung browser, all the major players have it, and the rest will probably get it soon. And Edge has no data channel. The Edge team decided, due to political reasons, not to implement the data channel at all. It is actually the 5th highest requested feature on their public tracker. They haven't even responded to it at all. And the reason is due to objective RTC, because Microsoft didn't want WebRTC, they wanted to make their own thing, which is only supported in Edge, and hopefully it's going to die soon, and they're going to implement it, hopefully. And yeah, of course. And one funny thing I wanted to mention quickly is Microsoft Edge is available for Android now. And it actually has 0.1 better score than Chrome. But that is not the most amazing thing. I'm not suggesting anyone switching here, but the most amazing fact, it's not running on top of the rendering engine of Edge. It's running on top of the rendering engine of Chrome. For Android, they switched to Chrome. So it's just a skin for Chrome, more or less, if anyone just want to try it out. So, we should probably talk about security for a moment, because that's always important, especially for WebRTC. Like you're sending video back and forth, you don't want that to get stolen. I read something called A Study of WebRTC Security. It's an 8K word piece that goes really in depth on the security. I would suggest reading it if anyone's interested in the security part. But taking the best quote from the piece, as a result of a strong focus on secure communication, WebRTC is currently regarded by some to be one of the most secure VoIP solutions out there. Building upon that with another source, if I wanted to hack you, WebRTC would be the last place I would start. It's encrypted by default, and there's no way of removing that encryption from occurring. You are safe when you're using WebRTC. But of course, you should look into it as well, but there's a lot of good resources on this out there. And like, it's also sandboxed, it's updated each 6 to 8 weeks, all that fun stuff. You don't have to worry. And what about room size? How many people can we connect together using WebRTC at the same time? Because like, if you remember, WebRTC is not a server-client model, which is a bit efficient on the connections, because like you have one connection per user to the server. But WebRTC is peer-to-peer. Each connection can potentially, or each client can be connected to all other clients. Adding just one more client to this can potentially add 6 more connections, which leads to this problem. As you're increasing the amount of people in the room, you increase complexity rapidly. So then you have a challenge to overcome. But if you just need a rule of thumb, 10. 10 for video. However, if you're using data, you can go much higher. It all depends on how much data, how often, and the amount of data you're sending each time. And like if you're just sending small text information, small chat messages, like probably can do 100 people, no problem. But you can also solve it by another solution, which I like to call a data channel host, which is one person being the host and the master, is taking the client-server model and mating it with the peer-to-peer model, having a client in the middle. But like, why would you ever do this? And this has actually been done quite a lot by a few video games I keep playing. Because the thing is, video game servers are expensive. Why don't we let the users host the game for us? So they connect all the users together, like in the peer-to-peer network that they're going to play together. Select the strongest computer with the fastest internet connection, and all the other clients drop their connection between them, except to the best computer. And the best computer becomes the server or the host for a session, even if it's just in the front end.
Isn't that what's happening with Pirate Bay? That one single person are hosting the website? Like they have let's say, files with the website, and everyone, it gets down. Everyone can upload it.
Yeah, it might be something like that. I haven't actually checked it, but it sounds reasonable actually. But you can technically do that in WebRTC as well now, but you need to have active clients at all time, of course. I think it's about time to talk about the latest news for WebRTC. What's happening over the last year? There's a lot of exciting stuff. WebRTC has become a candidate recommendation as of this summer, which means it's finally stabilizing, more browser support, and all that fun stuff. And if you don't believe me, here's the actual page. It says September because it's been updated since, but it came out in the summer. So if you're afraid coming into WebRTC because it keeps changing all the time, no, now it's stabilizing. Now you can learn it, and you can use it the way you learn it now is usable in 10 years. It should be, at least. And this is something completely new. Now we're getting screen sharing without a plugin. Like if anyone's tried WebRTC, you have probably seen that you can't get the user's screen without a plugin. But now we can, and this is so new, you can't find any good documentation on it at all on the web. But we're getting something called navigator.getDisplayMedia. That is something different from getUserMedia. But asking there for video, that triggers a pop-up for the user where they select the screen, tab, or window they prefer, and you get that as a media stream, which you can send to the other side and show in a video element. But this is not documented anywhere currently, as far as I saw, but it's coming soon. But that is not the amazing thing. It's only supported in one browser, and it's only supported in Edge. They decided not to implement the data channel, but they're going to be the first to implement screen sharing. What are they doing? But if you want to play around in it, it's working in Edge, and it's probably coming to the rest in the next version of Chrome or something like that. Probably before Christmas, at least. And something other. We have something called the transceiver. And now we're getting into a part where you shouldn't learn this unless you already know WebRTC. But just to give you an overview of what it is, it's a new and optional way of having more control over how media flows between clients. If the regular WebRTC setup is insufficient for you, like you need more control, then you can use the transceiver. It's more control for more complexity, in a nutshell. Like you can start sending video before the negotiations has even completed, which is nice. And it will allow you to distinguish between incoming video streams, because potentially with WebRTC I can attach 5 cameras to this computer and send all of them as separate streams to another computer. And you can use the transceiver to distinguish between them if you need that. And it's only supported in Firefox for now. This is probably coming to the rest. But we should talk about a few channel ideas. How can you use WebRTC in your own applications? These are mostly supposed to be inspirational, but if you want to implement them, just do it. It's always fun. Like one thing I could have done for this presentation is have a live share presentation where all of you on your mobile device connected to my computer, and each time I went to the next slide, I sent a data channel message, all of you, telling your browser to switch to the next slide, potentially. But of course then you will be looking on your phone all the time, so problems. And this is a big one. You can offload data transmission to the front end because servers are relatively expensive. Like if I have an application where you can do a lot of fun stuff, but you can also send files between 2 clients. You can send a file to your friend. But why would you want that file to go through your server, wasting server capacity and costing you a lot of money if you can just establish a direct connection with WebRTC and send it directly? That is one thing you have to think about with WebRTC, because you can use it a lot for sending data directly if it doesn't need to go through your server. And you can even, this is a fun fact, you can even use WebRTC for signaling for WebRTC. Imagine you have the setup. You have a friend A that's connected to you, and your friend C, A is connected to B and C, but you want B and C to connect to each other. Connecting in WebRTC is just the browser generating text information, and you need to get it to the other user. And you can just use the shared connection to A, and suddenly you're connecting to each other using WebRTC's data channel. Like, why is this useful? One example is if you're already connected to two people and want to connect another, or for example, if B and C loses their connection to each other, then you can of course use a signaling server, but that's slower because it's usually far away. But if your friends are close, then connecting would be more or less instant. You can use it to speed up the connection process if you already have a shared connection. And all of the examples I showed you can be solved using a server. But now we have a direct option. And in almost all cases, using WebRTC will cost you less and get you there faster than the alternatives. And in my opinion, WebRTC is a building block of the web of tomorrow. You will need it at some point for video, audio, or data. We're approaching an even more connected future. And WebRTC will help you create that future. This is a tool you should know, because there's so many use cases popping up now that you can have a direct connection between two clients without asking for permission. And of course, it's gratis. Yes, that is actually an English word, if anyone's wondering. It means free, if anyone's unsure. Of course, except for the signaling, but all projects usually have a backend anyway. And Turn, the relay server, if you can't connect due to your firewall. But Turn is something you actually can consider purchasing if you don't want to set up that yourself. And Mozilla has a great blog dedicated to advancing WebRTC, if anyone wants to read about the latest news for WebRTC. And of course, there's still some problems with WebRTC, like some small differences between browsers, but then you can use the adapter, the official adapter, which helps you to, like if there's differences in the functions you use between browsers or something fun like that, you can use it to have easier to work with cross-browser support. But that means we are at the end of our journey. I really hope you liked this presentation and learned a lot more about WebRTC, and I'm really motivated to run home after this and just make something in WebRTC. And I thank you for your time.